Gotten the trench filled back in, and it's nice and rainy, so by testing out the rapid shutdown, I won't be affecting any loss of real generation of solar today. But today I wanted to talk about rapid shutdown and the requirements, why we have it, and how it is actually actuated on these 18K PV and in most systems in the same manner. So this, you do have to have a placard with a permanently affixed sign that indicates for anyone in emergency services to understand what it is. This is a single press that will shut the entire system down, and then you rotate it and it will pop the button back out, and that will restart the system automatically when that button comes back out. So that button is basically allowing continuity on a loop of a wire, and I'll show you how it's wired inside, and then we'll go into some extra fire safety that I'm doing, which we've got this Kidde fire alarm and one of these Kidde SM120X relay features, and I'll go into that as well. But how this is wired, these inverters are all daisy chains together, and each one has this block here, which represents how it handles rapid shutdown, is wired to an auxiliary device. Without that, this would be your RSD stop button. This is inside, and you don't want that for code reasons inside exclusively. These are indoor-outdoor inverters, so you can do both. This could have been outside, and that could have been my RSD button. The purpose of that button is to ensure the safety of fire personnel trying to do either a roof entry to the building or get past the electrical equipment, which is likely to be energized if it is solar because of the nature of solar energy. So every one of the panels that comes in on these strings has a TIGO 2FA fire safety rapid shutdown module. That drops the voltage to, I believe it's 0.3 volts per module or per unit, and I have two panels on each unit. So it's a very, very low voltage, very safe. So if a roof entry had to happen and they had to break through a solar panel, there's a very low likeliness that fire personnel would be injured by way of electric shock. The rapid shutdown also shuts down the inverters themselves, so they stop outputting their AC current when that happens. So here in my AC combiner box, all of these breakers will stay active and on, but the actual EG4 18K PV units will stop the flow of AC output from that point. The really cool part is when you cleared that rapid shutdown button, so either you've pushed this button in and it has shut the entire system down, and then you just twist it to pop it back out, the system will just reboot itself. There's no need to have to go through the switches. Every once in a while, you might have to do a full hard restart of the system, shutting your batteries off and then kind of doing the walk through all the batteries to get the system back on. But the last time that I tested this, it was as simple as turning it off, shut everything down. The inverters get really loud. They pump out all of the air. They try and cool off their capacitors, and they basically just go dormant. Now, that is a manual switch. Now, what if I didn't have someone here at the house, and this room, which is obviously exceptionally safe, everything is done to code, so all of the DC conductors are in metal conduit, EMT, everything is exceptionally safe and really well wired. But if there were a thermal runaway or some form of a short in this room, it's such a small space that a smoke alarm could easily capture that first. So this would be the first indicator that smoke is happening in this room. There's one on the ceiling that is not wired to anything. That is just a simple battery operated unit. This unit, you can see, has a green indicator light. I have passed AC 120 from this receptacle over here back into this conduit box. And the purpose for that is, so that is a wired, and if that outlet were disconnected or the breaker was blown, that still actually has a battery in it. And I've actually mounted it through, just pop it out so you can kind of see. I put a little rubber grommet in there, and I just put lugs into the actual structure of the conduit box so that it had a nice fixed on holding spot. And that one is on this deliberately to indicate that it is part of the rapid shutdown. And there'll be a sticker on this. So if you're in this room and you wanted to initiate a rapid shutdown, you can actually hit the test button, and it will also put the system into rapid shutdown. How that is being done is through these Kidde relay power supply modules. Now, they come with a bunch of different ways that you can configure this to do different tasks. These instructions show you numerous ways that you can use it to unlock doors. That might be a way that the room that was normally locked becomes unlocked so that anyone can evacuate a building. There's also ways to have these wired into those pole-style fire extinguishing functions. Not fire extinguishing, fire alarm functions. And so on and so forth. Now you can see like there's a water flow switch. So there's all sorts of ways that this can be wired. On the module itself, it gives you all the directions you need actually. So obviously you put your black, which is your hot AC, onto the black hot AC that is going to the smoke alarm and from the breaker. And that needs to be a fused breaker, obviously. The white is your common neutral on the AC side. The red is the signal. So the signal that would be on the smoke detector comes off and connects to this unit. So there's only 3 wires from this unit that connect to the alarm itself. From there, they give you a bunch of different options as ways to wire it. So you can use this blue, this common pass-through, and I could easily attach this to the positive, the hot AC, and pass current through it so that it would be holding, for instance, a magnetically held door shut. And then as soon as that current is tripped, it could then have that signal removed. So it would remove the 120 volts from this line. There are also these other 2 lines. I believe gray is, yeah, that's the 9 volt. You can see there. And you have orange and yellow. So these 2 are your logic, the orange and yellow. And it's actually more of a pink color. I'm sorry, but whoever made this is really bad at color naming. That is definitely not orange. But regardless, how this works, I have my multimeter on continuity. So when I touch the 2 probes, you hear that beeping noise. And what it's saying is that I have a circuit that is closed, which is really weird because when you think about electricity in the form of flows of water, which is often referenced, closed usually means the flow has been limited. So I'm going to touch both of these little electrodes and you'll hear the beep. And so that is touching both these at the same time. Now, I put those little sleeves on, which I will solder on eventually once I cut the wire that's part of the system. So I'll take the finger off that and we're going to do a test of this system so you can see what happens. I tap this button once and I've got the beeping. And once the alarm goes off, this stops. And it'll do that beeping. And I'm sorry for anyone wearing headphones, and then it goes right back to having current flow through it. So what I'm going to do with that is knowing that if the alarm is going off, it stops the current from flowing between these 2 conductors. The rapid shutdown system, which in this panel here, starts with a red and black wire. And I just did that so I had 2 legs that I could easily distinguish. Which, by the way, those wires came from my grandfather, Howard's Doggett. I have a whole bunch of these spools of wire, and these are older than probably 99% of the people watching this channel. But always recycling and reusing and always finding a use for all of the things that I've saved for all over the years. But that's why you keep stuff right there. But that, on one leg of this rapid shutdown, I'm going to cut this leg open, essentially. And what that will do is allow me to solder in each leg from this. Now, you don't want to solder it in between the two legs, because then you'll be bypassing the button. The button and the alarm need to work at the same time. Either one of these can be tripped and it will cause the system to go into rapid shutdown. So be very mindful about the way that you wire this so that one doesn't bypass the other. Now, I'm going to push the rapid shutdown button just so that you can see what that rapid shutdown looks like. And at the end of this, once I've done all my rapid shutdown stuff, I will come back and wire this in, and I'll clip together the completed version of what this looks like in the case, which will be pretty much like what it looks like now, but these wires spliced in. Now, you're going to hear these inverters start screaming like crazy, and since my whole house is powered off of this, that light in that room is going to go out. So we're going to hit the rapid shutdown button, and we're going to count down. In just a couple seconds, you'll hear all those inverters kicking in. They're all getting mad, and the power's out. Just like that, within a few seconds, all of the inverters went into warning mode, and they're all blowing out a ton of heat to get all of that AC capacitance out of the system. And just like that, there's no power at my house. And so this is when I will use that flashlight, wire in all of this, and then I'll show you what it looks like at the end. Now, once I'm done, it will allow me to have a fire alarm that triggers that, or the button on the exterior of the building. So that is the first bit of this. So I reset the RSD button by just twisting it. It pops back out. And then when I went to go test the rapid shutdown button from the fire alarm, the duration to which this actually shuts power off is so short that it doesn't invoke the rapid shutdown. The rapid shutdown has a fail-safe mode, so if you accidentally bump the button, you have enough time to undo that action so that it won't shut everything off. But I can't actually invoke it from this unless there's an actual alarm. So it does work, and it will work as intended. It just needs the rapid shutdown to actually be a real fire. So I'll throw the breaker back on, and we have power back to the house. Everything is up and running. I use those heat shrink tubings that I love so much. These little guys, I'll put a link in the description for those. This Kidde fire smoke detector, I should call it, and specifically this module, the Kidde SM120X, and that will allow you to put in a fire alarm that will be the actuator for your rapid shutdown, should you not be available to put the system into rapid shutdown yourself. And if the alarm stops sounding, it'll automatically allow current to flow back through that switch, and then the system will power back up and your whole world will have power again. These are really awesome units. They allow for a lot of flexibility in the way that you design your system and the safety that you put into that system. So if anyone else there's looking for ways to make your system a little bit safer, a simple smoke detector might be the way to do that. Obviously, if you have any questions, put them down below. My next video, I've been getting a ton of questions about the size, the scale, how I calculated this from friends and from online. So if you have any questions about this system specifically, put them in the comments below here, and I will try and put all of those in the next long format video that I do, which will be going from tip to tail of this entire project, all of the designing, all of the calculations, all of the things that I learned, all of the things that you should know when designing a system like this. So cheers. I hope this helped. I hope your system is safe. And for a couple bucks, it makes it a lot safer just to throw a fire alarm in there. Cheers.